As a species, this is what we've always been about, right? Is exploration and looking out to the beyond the frontier.
That's just natural. It's in our DNA as humans to wonder.
Space exploration allows people to innovate and dream.
One of our big objectives in astrophysics is to learn about what the universe is made of, and how it began and what it's going to become.
It's going to go out there and map much of the visible sky.
It will give us the same quality of infrared imaging that we got from Hubble, but with so much more area.
Every image you've seen from Hubble, imagine making it 100 times bigger.
So W-FIRST is more like a wide-angle lens, and JWST is much more like a telephoto or a zoom lens.
Atoms, the stuff that makes up us, makes up everything we see, makes up only 5% of the universe. The next 25% is in the form of what we call dark matter.
Dark matter is actually a placeholder name for something that we don't actually know what it is.
W-FIRST will map the invisible universe with a technique known as gravitational lensing. So by looking at distant galaxies that we can see, that we can observe, we'll be able to measure the tiny distortions of those galaxies caused by the gravitational field of everything between us and them.
So it's a way of making a map of all the mass in the universe.
We will be able to map the large-scale distribution of dark matter and learn more about its properties.
And W-FIRST is ideally suited to it because it's such a wide field instrument.
The remaining 70% of the universe is even stranger. It's made up of what we call dark energy.
Dark energy is simply the name we give to whatever it is in the universe that's making our universe accelerate. So with W-FIRST, we'll use several different techniques to measure the history of the universe's expansion, all the way from many, many billions of years ago up to today.
We want to look back in time, back in space-time, to the origins of the universe, to back in the Big Bang. We have to look back at stars that are accelerating away from us.
And so the light that they're emitting, even light that's visible light to us, by the time it gets to us and the universe has expanded, that light is in the infrared part of the spectrum.
We think that a lot of the habitable planets emit light in the infrared wavelength.
One of the important parts of W-FIRST scientific program is completing the census of exoplanets.
Exo means external to the solar system, so it's planets orbiting another star.
We will be able to detect thousands of planets around distant stars.
That's why we need things like the coronagraph on W-FIRST, which is designed to find planets that are closer to their host star, more likely to be habitable.
And what we will do with the coronagraph is we will be able to study the atmospheres of giant planets in great detail.
W-FIRST really builds on the efforts that NASA and L3 Harris have worked on together.
We built the backup mirror for the Hubble Space Telescope. For Chandra, we built the high-resolution mirror assembly, which enabled the imaging of very faint galaxies. We've done all the integration and test of the James Webb Space Telescope.
We're leveraging the existing 2.4-meter telescope and augmenting and refurbishing it and adding additional capabilities.
So that this is a mission that, while powerful, is a much lower risk mission.
For very little delta cost, all of a sudden you got a tremendously large increase in capability.
That really helps us deliver a more affordable and efficient solution.
With a mission like W-FIRST, we're also learning fundamental physics. And when we have advances in fundamental physics, they often lead to things that end up being surprisingly practical.
We learn about new materials, we learn about new processes. And once we figure those things out for space, we bring them back for benefiting Earth.
W-FIRST will really help us look into the heavens and explore the edges of our universe.
I think that's just going to give us so much data that we'll be able to learn about something new, and that's extremely exciting.
What could be more exciting than discovering that there's, life on planets other than our own?
I just want to see what it is that's out there, what we're going to find.